All right, so today we're going to go ahead and go over how to convert from grams all the way to particles. So this is a two-step conversion, different than our past conversions because our last conversions, they were only one step. So you can actually do this in one step, but I'm going to show you a two-step method, then I'll show you the one-step method. Okay. So whenever we're going from grams to particles, you have to follow this path. You can't just go straight from, and I put particles here, but you can use particles, atoms, molecules. It doesn't matter. Okay. So let's say I'm going from grams to atoms. I have to first go from grams to moles using molar mass. I already know how to do that, right? So I go from grams to moles using molar mass. And then I go from moles to atoms using Avogadro's number. Okay, and we'll just abbreviate there. So we've done both of these steps. So basically we're just doing two steps. Okay, and you could also go the opposite way where you go from atoms, then back to moles and to grams, which is what I have here. So you have atoms, back to moles, back to grams. So you have to take this path when you're solving these problems. Okay, let's go ahead and look at an example here. So for this first example here, my example is asking me how many atoms are in 2.6 grams of CH4, methane. Okay, well, what I'm doing, again, I'm starting with grams, so I'm going to go from grams, then I'm going to go to moles, then finally to atoms. Okay, and if it's particles or molecules, it's still the same process here. Okay, so first step I want to do is I want to turn grams to moles. Well, I got to know the molar mass of CH4. So the molar mass of methane is, well, carbon's 12, hydrogen is 1. So that's going to be, if I were to do this, let me do this here on the side. The 1 mole of CH4 would equal, again, this is 12, this is 1. It would be 12 plus 4, which give us 16 grams. Okay, so we're going to use that to do this first conversion here. So I have 26 grams of CH4. So I have 26 grams of CH4 times a fraction, right? So what I'm starting with is grams. I'm going to go ahead and put grams in the bottom. Grams go in the bottom. 1 mole of CH4 goes on top. I go ahead and I've done this type of math before. I multiply, then I divide by the bottom, so it'd be 26 divided by 2. So if I have my calculator here, it'd be 26 divided by 2 would give me 13. Okay. Actually, sorry, 26 divided by 16. All right, 26 divided by 16. That would give me 1.625. I'm going to go around to that first decimal here and make it 1.6 moles of CH4. Okay. Then I'm going to take this number and let me just rewrite it here just for the sake of making things a little bit easier to follow. So I'm just rewriting this here. Moles of CH4. Then I'm going to go ahead and I'm going to turn this into, go from moles to atoms. So I'm just doing Avogadro. I'm using Avogadro's number to do that, right? So I know 1 mole of CH4 equals, if we're looking for atoms, right, equals, well, 1 mole always equals a certain amount of atoms, which is Avogadro's number. So we'll go ahead and put that here. And then that will give us our answer, right? Sorry, I didn't show this canceling. Moles cancel, moles cancel. I'm left with 1.6 times Avogadro's number. So I'm basically left with my answer here times 6.02 times 10 to the 23rd. Enter gives me 9.782 times 10 to the 23rd. I round to that first decimal. That would give me 9.8 times 10 to the 23rd. My units would be atoms of CH4. Okay, so in other words, if I were to, so I can actually predict, or not predict, but I can calculate how many atoms are in a certain amount of mass. So I can get a mass and I can figure out how many atoms there are. So just by simply doing this stoichiometry problem here. Okay, all right, so let's go ahead and now we're going to do the opposite, right? So I'm going to have, Okay, here we have a slightly different but similar problem. In this problem, it's asking, what is the mass of 5.2 times 10 to the 24 atoms of H2O? Okay, in other words, in this problem, I'm starting with what I'm given, right, which is atoms, and I'm trying to find mass. So I have atoms, and I want to convert that first into moles, and then finally into grams, which is mass. Okay, so I have to go through this process. So first, let's do step 1, which we've done before. We're going to take this and we're going to turn this into moles using Avogadro's number. So I go 5.24 atoms of H2O times a conversion fraction. Sorry, let me rewrite this here. This should be 5.2 times 10 to the 24 atoms. Okay, so we have 5.2 times 10 to the 24 atoms, and we're going to go ahead and put Avogadro's number in the bottom, right? Because if we start with atoms, then we want atoms in the bottom. So we have atoms in the bottom, and what we want goes on top, which is 1 mole of H2O. Well, we know 1 mole of H2O always equals a certain amount of atoms, which is Avogadro's number. Okay. So I'm going to go ahead and do this math. I'm going to put this in my calculator and divide it by this whole bottom thing. Okay, you should be getting something. If you're getting something times 10 to like the 46, you're probably doing something wrong. So if I'm putting this in my calculator, go 5.2 times 10 to the 24. Save that in my calculator. Divide by. So I want to go ahead and divide by the bottom, which is Avogadro's number, making sure to put that in parentheses. So times 10 to the 23rd would give me 8.63. Okay, so I have, let me round to that first decimal, so we'll go 8.6. So I have 8.6 moles of H2O. Moles of H2O. Then the last step is simply what we've done before. We're turning those moles into grams using the molar mass of H2O. Well, the molar mass of H2O is, the hydrogen is going to be 2, right, because each one is 1, and oxygen has a mass of 16, so this has a mass of 18 grams. Okay, so mass of 18 grams here. Okay, so now let me just kind of rewrite this down here so you can visualize it a little bit easier. So we have 8.6 moles. I have 8.6 moles of H2O times, if I start with moles, I need moles in the bottom. I'm looking for grams, right? So grams go on top. I know that 1 mole equals 18 grams. So I put that on top. That is my final answer. 8.6 times 18 grams. Cancel, cancel. 8.6 times 18 gives me 155.48. Rounding to that first decimal will give me 155 point, round to the first decimal, 5, because that's greater than 5, right? Grams. And I can put grams of H2O. Do not forget units. You need to have units. Try to be specific as to what it is.